So hello everybody, thank you for attending this webinar. I'm Valérie Leprince. I'm working as an independent consultant, and I will just make a short presentation about why we should care about ductwork airtightness. So first we will begin with the impact of ductwork airtightness, and we'll have a small view on what is the ductwork airtightness level in some European country, and what are the requirements in European country, and at the end a presentation of the next speakers. So what is the impact of ductwork leakages? In fact, the impact of ductwork leakages depends on whether they are in the supply ductwork or in the extract ductwork, outside the conditioned space or inside the conditioned space. Regarding its preconditioned air, losses may induce losses of preconditioned air if they are outside the conditioned space. Also, it may induce overventilation, okay, or in the extract ductwork, the air temperature decrease if there is leakage outside the conditioned space. Regarding the fan energy use, in fact, there is two things may happen. Either the fan will compensate leakages. That means that the fan will run faster and faster to maintain the hygienic flow rate at the air terminal devices, but this means that leakages will increase the fan energy use. Or the fan will not compensate. That means that it will at the same speed, whether there is a leakage or not, which means that you will have a decrease of the hygienic flow rate because part of the flow rate is going through leakage instead of going through air terminal devices, and then you may have a decrease of the indoor air quality of the building. So this is a theory. Now in practice, how much does it represent those leakages? We have done a study, we have done a replication of a real ductwork system here, and that was initially class C, and that has been drilled and drilled and drilled again to reach 1.5 times class A. So class A was very good, class C was really good, and 1.5 times class A was quite bad, I would say. And we have done measurements of the fan energy use, and also we have developed a calculation method to know what would be the impact of the leakage on the fan energy use. What we found out is with the measurements going from not airtight at all ductwork to a tight ductwork will decrease the fan energy use by 46%. This was done by measurements, and with our calculation method, we obtained 48%, so more or less the same. Which means that by having an airtight ductwork, we can divide the fan energy use almost by 2. And this is not the only studies that have shown that, something like that. For example, in 2011, CEN has published something saying that the total energy consumption related to ventilation can be reduced by over 30% with an airtight ventilation system. And Dyer in US in 2011 has shown that on a pharmaceutical plant, over a 30-year of life of the building, the energy penalty of duct leakage is more than $1.3 million. So this is not at all negligible. So if we have ideas, I would say, on what is the impact on the fan energy use, there is very few study on the impact on heating and cooling, energy. So this means that we need more study to know what would be the impact on heating and cooling of when the air going in the ductwork is preconditioned. Also, regarding indoor air quality impact, with the same ductwork I've presented at the beginning, we have also tried not to compensate the flow rate. That means that we've remained at the same pressure at the ductwork, which was 90 Pascal, and we have not increased the pressure at the ductwork. And so in this case, of course, the fan energy use was less, but we have a decrease of flow rate at air terminal devices of 10%. So that means a decrease of the indoor air quality in the building. Also, we suspect that if we have a lot of leakages in the ductwork, we may have an increase of dust in filter, heat exchanger, and ducts themselves, and also in sensitive areas such as operating theater, clean rooms, it may weaken the contamination protections. Also, some more studies in this field are needed. Now, what are the ductwork leakage levels? So I will show you results of a very old project. That means it's almost 20 years ago now, but still it's a reference on that. And so at the end of the 19th, we see that in France and in Belgium, where most buildings were 3 times Class A, while in Sweden they were already Class B. So things are changing, but slowly, at least in France. But yeah, so we see that going from 1.5 times Class A to Class C may reduce the energy use of 50% of the fan energy use. So there is some work to be done. This has been confirmed in a US study on 11 large buildings, and it has been shown that the leakages of the ductwork are representing 28% of the fan flow. Now, what is the evolution in regulation and programs? So in Sweden, there have been a requirement on airtightness. I think Lars will talk about that for 50 years now, so they have a good experience in this subject. In Portugal, for 10 years now, they have a requirement in some kind of large building. In Belgium, the regulation, the calculation method in Belgium and France is taking into account leakages, but there is no minimum requirement. In UK also there is some test mandatory for some systems. And in France, the calculation method, as in Belgium, is taken into account the airtightness of ductwork. And also there is a label for 4 years now, FNRG Plus, that require the Class A, which is not really, really good already, Class A, but it makes people realize that ductwork airtightness is important and how we perform the test and so on. And so now in France, airtightness in ductwork is beginning to improve, I would say. Also, we have done a survey in the TightVent Airtightness Association Committee. So this is a group of airtightness tester and stakeholder in airtightness in Europe to try to understand how ductwork airtightness was taken into account in regulations. In fact, among the respondents, so you have here the country that have answered the questionnaire, it seems that there were only France and Belgium that were considering ductwork airtightness as an input of the energy performance regulation, but in the two countries there is no minimum requirements, and that the awareness was really low regarding ductwork airtightness. And when we ask the TAC committee what is in their view the progress needed to promote the ductwork airtightness, most of them answer that there were a need for quantified impact in terms of energy use. So as for building, airtightness, the main driver for change will probably be the energy use. So research are needed in this topic to have a better knowledge of the impact. So thank you for your attention. I think now Lars Hack from Sweden will present us as the convener of the WG3, so the standardization committee on this subject will present at the European ductwork airtightness class and ongoing standardization work, and also what is going on in Sweden, which is I would say the model country for airtightness of ductwork. Then Tajima Mazaki from Japan will make us a presentation about what is going on at ISO also and in Japan. And at the end, Rodrigo for Gonal, what is the market trend in Spain and Portugal. So thank you for your attention.